Well, hello everyone. It's good to see you all here. I hope you had a great coffee break. First, I'd like to start with a quick introduction. My name is Çağıl. You can find me on GitHub, Twitter, and Mastodon. I'm a lead backend engineer in Kraken. I also have some other affiliations that I want to mention. I'm currently serving as the Vice President in the Django Software Foundation. I'm a co-organizer of London Django Meetup. And PyCon Turkey. I'm a proud member of PSF and PyLadies. And I also help organize over 10 Django Girls workshops since 2015. So if you want to talk about any of those after the talk, please come and find me. And let's come to today's agenda. Today, we are going to talk about large-scale collaboration and how to best structure your Django code base to enable it. I will talk you through the architectural style that we use in Kraken and how it helps us achieve large-scale collaboration within our tech team. I will explain some of the details and some of the implementation. While doing this, we will talk about what problems it solves, and I'll mention several pros and cons of using layer architecture. I'll demonstrate the concepts and ideas mentioned with some dummy coding examples. Oops. So, to tell a bit more about Kraken, Kraken provides an advanced software solution for energy and utility providers worldwide, integrating renewable energy management, customer service, and automation. The Kraken platform helps optimize operations, reduce costs, and enhance service quality, supporting major global utilities. We help them transition to decentralized and decarbonized energy systems. On the other side, in our tech team, we have a pretty big code base with about 1,000 developers working on the same monolith. With an average of just over 150 deployments a day, we have a super fast iteration cycle. While doing this, our main focus is robustness and efficiency of the systems we are building. Today, we're going to focus on how Django and our architectural style help us. So let's take a look at how we utilize layered architecture to enable these, and I hope you can take home a few learnings today. I'm sure you have been there. Have you ever worked on a project that started small and then got really large? Like, you throw a party for 5 and 100 came. Everything imports from everything else, and whenever you change one thing, it's connected to 10 million other things. You have no idea sometimes where to put stuff, and you don't know where to find stuff. Without a formal architecture in place, it's more likely that as your project grows, as your team grows, you will end up with a big ball of mud. In other words, an application that's tightly coupled, fragile, difficult to change, and lack a clear vision or direction. So let's explain a few things before we start. Let's start with what's an architectural style. An architecture style describes the macro structure of a system. helps you put a formal architecture in place for your software and helps define the basic characteristics and behavior of an application. Different architectural styles offer different approaches to designing software systems, each with its own set of principles, benefits, and trade-offs. Choosing the right architecture style depends on factors such as scalability requirements, team expertise, and the nature of the application being developed. You should choose the one that meets your specific business needs and goals. We're not going to talk about different architectural styles today, but I would love to hear that talk from one of us one day. In software architecture, layers refer to a way of organizing and structuring software components into distinct groups, each with a specific responsibility. Which brings us to layered architecture. This approach is known as layered architecture, or sometimes called as N-tier architecture. Each layer has a well-defined role and interacts with adjacent layers in a controlled manner. It promotes separation of concerns, modularity, and maintainability. This particular style is layering by technical area. Like, you can think of it as front end, back end. But that's not the only option. You can layer in other ways. For example, like in the clean architecture or hexagonal architecture, which we're not going to go into detail today. So let's look at the Django. Django uses a modified version of the model view MVC architecture called model view template, MVT. In Django, views depend on the models, and templates depend on the views. For instance, if you want to add something to a template, it needs to come from the views. And similarly, if the view needs data, you need to put it, you need to store it in the models. We can say views and templates form a distinct group that is responsible for displaying information to the user and interpreting user comments. Whereas models forms an adjacent layer, and we can call this data layer. It manages the storage and retrieval of data from the database. Django's model view template forms a layered architecture. How we choose ours? We use, in Kraken, we use Python and Django for our big monolith application. And that's why picking layered architecture as our architectural style was a natural choice. One of the powerful features of the layered architecture style is the separation of concerns among components. Each layer is dedicated to handling logic relevant only to its specific technical area. For instance, components in the presentation layer, which you can read as front end also, focus solely on presentation logic and nothing else. For example, it's responsible from displaying the user data. While those in the business layer exclusively manage business layer, like how to collect that user information. It's not responsible, and it doesn't care how to display it. Such categorization facilitates the creation of efficient role and responsibility models within our architecture and enables different teams and groups to govern the areas that they're domain or area expert. This also streamlines the development, testing, and maintenance of packages and modules, particularly when well-defined component interfaces and contracts are established between layers. So, next, let's look at the key components of our layered Django project in Kraken. So, we have interfaces layer, which is entry points plus all presentational concerns, like all. Below it, we have application layer, which is responsible from orchestration logic, like coordination of everything. Domain layer is responsible from business logic, and data is where persistent logic is located, in particular relating to databases. And dependencies flows downwards here. Let's look at the layers in a bit detail here. So the data layer, we said, where we locate persistent logic. This is a very Django-heavy layer. We have Django models, managers, and migration files defined here. And one principle we are trying to follow here, which I think we are really good at, models should be kept thin. Like, we avoid putting business logic on them. A bit not super Django-stick, Django-nic, to follow Pythonic. But yeah, we keep models super thin. I think we have around 600 modules in this layer, and yeah, compared to other layers, it's a thin one. Here's an example folder structure that you can see. It's a quite also flat layer. We have different components under it. So on top of data layer, we have domain layer. Domain layers is where core reusable business logic lives. So that's where we put the business logic carton. Kraken core has the concept of two kinds of procedure governed by different rules. First is operations. Operations change state in some way, for example, by writing to a database or causing an external side effect. Most often, these would be called comments, not operations, but we call them operations. We find it more intuitive. And the second type is queries. Queries are read-only procedures that have no side effects. So domain layer is a large layer in Kraken. It's our fattest layer. We make sure the modules in domain layer is discoverable. That's why we organize packages by domain category and subcategory, as you can see here. And we locate queries in modules called queries and operations in modules called operations. Let's look at a dummy coding example. This function, this domain layer query function, fetches an account user record by ID. What it does is it goes to the ORM, fetches the data, it serializes the data, and turns it back. Simple. Let's continue. Let's next look at the application layer. We call the entry points in this layer use cases. Each use case is responsible from one action. Interfaces may only change anything in the database through a use case. So all our interfaces, all our views, all our APIs can only change data through a use case. And once use cases are completed, changes will persist. These are the main principles. But really, it's again, super thin layer, like the data layer, and its pure responsibility is the coordination of operations and queries from one or more domains. database transactions, logs, queuing infrastructure, and event logging. And to note, this layer is sometimes called the service layer for those who are more familiar with the layered architecture. So let's look at a coding example. So this is a dummy, a potential use case from our code base. It updates the user preferences. So what it does, it goes to domain layer. It queries the domain layer for the current preferences of the user. It makes a second call, an operation call to the domain layer to update the preferences. And once we make the changes, it publishes an external event to those, for those channels to act upon those signals. And then it does logging. It's also responsible from the transaction. You can see the atomic decorator at the top. And that's it. Super clean and super easy to read, test, maintain, and change. Let's go back historically a bit. We introduced the application layer because it was challenging to determine which functions in the domain layer were the right ones to call. Domain layer contained a mix of low-level and high-level functions, which caused confusion. To address this, we moved the high-level functions to the application layer. This change, among other things, improved our ability to test and manage these high-level functions. In the application layer, we enforce strict rules and we use linters to ensure quality. Specifically, we enforce certain docstring and testing patterns at this layer, which I mentioned in one of my other talks about coding conventions. Yeah. So let's move to the next layer, interfaces layer. So interfaces layer is where, okay. The role of the interface layer is to translate requests from different protocols, such as, but not limited to HTTP requests, into domain requests, and conversely translate domain responses into appropriate response, responses into appropriate form. For example, converting an application exception into an error response. So it has Django URLs, Django views, Django forms, Django REST framework serializers, GraphQL queries, GraphQL mutations, Celery tasks, because they're also entry points to our applications, and Django management commands, and templates, because templates are also a presentational concern. The main advantage of this layer that it locks out, separates all presentational concerns from the application and domain layers. This allows us to build powerful domain models without the distraction of presentation-related issues. Let's look at one example from the interface layer. So this is a view, a dummy view that creates an account. What it does, remember, we're at the interface layer, the bottom layer is application layer. It makes a call to application layer to the account use cases to create the account with the parameters, handles the exception, and on successful operation, it returns a success message and renders the response. We have many other interfaces, like API sites, consumer side, I mentioned seller task, system task, cron jobs. And this one is a support side example. It's the back office platform we have. We use the same use cases in the other interfaces. Like we call the same use case from our GraphQL API. And when we are migrating clients from within our management comments. So this gives us a great power of reusability. So that's the end of dive into the layers. Let's talk a bit about import linter next. We use import linter to enforce our architectural style. Import linter is an open source Django package authored by David Seddon. And I think maybe we already listened a talk about it in one of the DjangoCon Europes. It's a tool that verifies your project's architecture by analyzing module imports and checking them against rules defined in a configuration file. The configuration file contains one or more contracts. You see one contract here. Each contract has a specific type which determines the rules it will apply. For example, here, if you can take a look, the type is layers. The layers contract type allows you to check dependency direction from high to low, ensuring proper layering. It has other types like, yeah, I'm not going to go into detail now. So we have several configuration files with different contracts, each tailored to different aspects of our architecture. And import linter is integrated into our deployment pipeline. So any code that does not follow the architectural rules defined by those contracts will fail the test. Next, I'd like to briefly talk about another principle of layered architecture, open, closed layers. In layered architecture, layers can be either open or closed. What does that mean? A closed layer means that as a request moves from layer to layer, it must go through the layer right below it to get to the next layer. And the layer below that after that. I mentioned about how, the historical story about our application layer, how it's born out of the domain layer. That hypothetical version of our architecture was an example of all layers being closed layers. A request originating from interfaces layer must first go through the domain layer and to the data layer in this version. And when an open layer is present, requests may pass through that layer to the next layer below that one. In our case, application layer is an open layer. I mentioned that interfaces may only act through use cases in applications layer. And interface code can also call directly into the domain layer, skipping application layer, to for view-only requests. And this is, at application layer level, is our open layer contract within closed layers. So let's look at another example. This time, we are looking into a wheel that doesn't do any database change. So it skips the application layer and goes directly into domain layer and uses a domain query to fetch the data required, render, and display. We talked about some advantages of our layered architecture, but before finishing, I also briefly talk you through on what is not working so well. We have an old code base, almost 9 years old, and it's growing. We didn't introduce all these rules from the start, and even though we have the architectural style set, you can still find a lot of legacy code in the code base. Previously, we looked at one of the contracts from our import linter configuration. What we haven't looked at is the ignored checks in that contract, and the list. It's not exhaustive, but it's not one line, I promise. We are trying to actively burn those down, but we, from time to time, introduce also new ones, unfortunately. In a large-scale collaboration setup like ours, you need more than conventions, you need more than agreements to enforce your architecture style. The layers, those are defined to be close, are not always so close. There are a lot of violations, as I mentioned, and import linter, unfortunately, doesn't support closed layers yet. So, you're as good and as complete as your tooling, it's safe to say. An improvement we want to implement is having real closed layers instead of open layers, and all over closed layers. It wouldn't be incorrect to say that we sometimes feel like we are playing against Django. Django makes things so much easier that we tend to compromise. We still have Django ORM objects throughout the entire code base, and it's a everyday debate for most of us. But it's not fair to put it all on Django, as something I haven't mentioned today is the domain-driven design. And we also find it difficult to follow a DDD approach within our current architectural style. So, last but not least, we also like to have clear contracts within the layers, vertically, as we do between layers, which is an open problem at the moment. Which brings me to my last slide. So to sum it up, the structure and organization provided by our layered architecture facilitates collaboration by promoting modularity, clear separation of concerns, defined interfaces, and standardization across the code base. The hierarchical and loosely coupled nature of it provides the flexibility and scalability needed to accommodate growth and changing requirements over time. I'd like to thank you all today for listening to the talk, and I'd like to finish by saying, before questions, if you want to take one of those lovely Kraken plushies home and to ask more questions, you can find me in our booth. I can answer those questions in person right after our draw for these plushies and 1 o'clock, and thank you.